All right, our 1.11 is over variation. We have three different type of variation. One of them is the direct variation. The next one is the inverse variation, and we have a joint variation. For direct variation, as x increases, I would say y is also increasing. Vice versa, if x decreases, y will decrease. This is usually a linear equation. Compared to the other one, I should write equation here. Compared to the other one, the inverse variation, y is inversely proportional to x. Note that on all of them is a proportion. This one, as x increases, y instead is decreasing. The parent function for this first one was linear. Compared to the second one, the parent function is rational. It's a rational function because that's your 1 over x. Joint variation usually involves more than one variable. Z is jointly proportional to x and y. In other words, z, it will give you again a linear equation, but this time you have double variables on the left side, on the right side, and one single variable on the other side. So as x increases and y increases, z will also increase. K is called the constant of proportionality. Let's go straight to the problem number 1. It says, during a thunderstorm, you see lightning before you hear the thunder, because light travels much faster than sound. The distance between you and the storm varies directly. This is an important information. Varies directly as the interval between lightning and thunder. So here we have a direct variation. Now let's go ahead and use that direct variation. Here it says the distance, I'll call that d, varies between you and the storm. I will say k times t, k being the constant of variation. Because k is unknown, let's go ahead and read the next one. It says, suppose that the thunder from a storm 5,400 feet away takes 5 seconds. In other words, t is equal to 5, d is 5,400. The only thing we don't know is k. So I will divide both sides by 5. And if I divide both sides by 5, I get k is equal to 1080. K does not have a unit. It is the constant of proportionality. Now that I have k, I can now rewrite the equation and say d is equal to k, which is 1080 times the time. I will go on to the next question. It says, what does the constant of proportionality represent? Well, k is, one way of finding k is to say is the distance over the time. In other words, it's the rate, or I would say the rate, constant of proportionality, I will call it the rate because it's the distance over time. I can call that the rate, or also call it the speed of sound. In this specific problem, it is also the speed of sound. The proof is rate or speed of sound are both expressed in distance, are both distance over time. So this one will be 1080 feet per second. Here I didn't put the unit, but here, since I'm making it similar to the rate, I will call it feet per second. If you don't remember this, you should probably remember that the distance is equal to the rate times the time. Let's go ahead and look at C. If the time interval between lightning and thunder is now 8 seconds, how far away is the storm? Here, all I got to do is substitute the time with 8 seconds. And if I substitute it, I will go ahead and solve, and I will have the distance is equal to 8640, and this time is in feet. Let's look at problem number 2. I will save the time to give you time to read. In the meantime, I will go ahead and highlight very important information, such as inversely proportional. That's an important information. What is inversely proportional? We have constant temperature also, that is important. The pressure of the gas is inversely proportional to the volume. So pressure and volume are also important. Now, because it's inversely proportional, I know that the pressure is inversely proportional. I'm using the formula for inversely proportional. Now, I know that the pressure here is 50. K is something that I don't know, over 0.106 or 0.106. If you cross multiply, you end up with K is equal to 5.3. And that's again is your constant of proportionality. To rewrite the equation, I would therefore say P is equal to 5.3 over V. And this will be my equation. B says if the sample expands to a volume of 0.3 meter cube. Well, at this time, I already have the equation, so I will say P is equal to 5.3 over 0.3. And this is equal to 17.667. And the unit, I keep the same unit. And here is rounded to 3 decimal places. You just make sure you keep the same unit. I'll put approximately here. All right, let's jump to problem number 3. Newton's law of gravitation says that two objects that with masses m1 and m2 attract each other with a force F. So the force F, that is jointly proportional to their masses and inversely proportional to the square of the distance. Well, here I have 3 different variables. So I know that F is jointly proportional, so I start with a K, with their masses. So I would say K times m1, m2. But inversely proportional to the square of the distance. So R squared on the bottom. Jointly on top, inversely on the bottom. From here, since I know already the equation, is my equation. The only problem is K. K here in this specific problem is the constant of variation. This is called the law of gravitation because K in this law, instead of having K, we will have G. So I will write it as F equal G times M1, M2 over R squared. This is the formula that you would probably see if you Google this. What happened to the force if I double? Express Newton, we did that. Use the traditional notation G for gravitational constant of F. And this is it that I did. Now I want to know what would happen if to the force if I double M1. Let's go ahead and double M1. So if I double M1, I will have F is equal to, again, this is an extra part. I will have F equal to G times a double M1, M2 over R2. My job, R squared, my job is to know what will happen to F if I double M1. Now at this point, I will have an extra 2 here, so I will have F is equal to 2 times G M1 M2 over R squared. In other words, doubling M1 will double F. So double M1 will double F. Now, what if instead of that, what if we double F instead? So let's say I double F. If I double F, it means I'm saying 2F. By doubling F, I say 2F is equal to G times M1, M2 over R squared. What will happen to the this one will be required to know what will happen to the mass. So that's not quite important. So I will just leave it like this. Instead of this, I would like to double R. Let's double R. If I double R, I get F is equal to actually G M1 M2 over 2R squared. Now, doubling R, I will end up with G M1 M2 over 4R squared. If you double your R, you end up quadrupling your F. So I will end up with 4F is equal to G M1 M2 over R squared.